Hello. In this video, we want to show that the m by n grid is not Hamiltonian when both m and n are even. Not to make a confusion, 1 by 1 grid looks like a square, like this. And 2 by 2 grid looks like this. So for even m and n, to show that the m by n grid is not Hamiltonian, actually, we want to show that the grid is bipartite. And we want to show that the graph has odd number of vertices. Then the graph cannot be Hamiltonian. So first, we want to put the m by n grid with one corner at the origin 0, 0 in the first quadrant in the plane. So like this. So when n is equal to 2 and n is equal to 2 case, you can see, so here, so I want to put one corner at the origin here, okay? And then we want to color the vertices with the two colors, okay? There is a rule, okay? Color each vertex as 1 if the sum of its coordinates is even, otherwise as a 2. So like this. So look at this corner. This is 0, 0. So the sum of the coordinates is 0, which is even. So I want to assign 1 in here. And this is 1, 0. Okay, the sum of the coordinates is odd, so I want to assign 2. This is 2, 0, so I want to assign 1. And this is 0, 1. So I want to assign 2. Okay. So if two vertices are adjacent, then you can see the parity of the sum of the coordinates are different. Okay. So the vertex set of the m by n grid can be partitioned into two parts. Okay. A, the sum of each coordinates is even, and B, the sum of each coordinates is odd. And each partite set, if you pick any pair of two vertices, they are not adjacent. So we can conclude that this is bipartite. And now, because m and n are even, so we can easily see that the m plus 1 times n plus 1 is odd, because n plus 1 is odd and n plus 1 is odd. And the m by n grid has n plus 1 times n plus 1 vertices. So this graph has odd number of vertices and is bipartite. So this cannot be Hamiltonian. Well, before we end the video, I have something to say. Well, I think some of you who are interested in graph theory but haven't taken the AMS 301 course offered by SBU might be confused by the term circuit. I want to point out that the term circuit in the textbook used in AMS 301 is actually used by most graph theorists as a cycle. Thank you for watching.